Write the expression as a logarithm of a single quantity. So in order to do that, we will condense these logs in each example into a single natural log. And in order to do that, we need to have the properties in mind that when you subtract two logs, that uses this property that the natural log of A minus the natural log of B equals the natural log of A over B. So when you keep this in mind, that the natural log that has a negative in front of it, the argument of that natural log will go into the denominator. So this condenses into the natural log of x minus 2 over x plus 2. And that is the answer for number 1. We have written a single logarithm. For this next one, before we are able to condense this using subtraction and addition, the first thing we need to do is get rid of these coefficients. If you go back and look at the properties, the addition and subtraction property here do not allow for constants to be multiplied in front. So the first step that we need to do here is move the 2 up here to the power of x, the 3 up here to the power of y, and the 4 up here to the power of z. So that'll look like this. The natural log of x squared minus the natural log of y cubed plus the natural log of z to the 4th power. Now that there are no coefficients in front of these logs, we are able to combine these logs together. And that'll look something like this. You can see here that the 3 logs have been combined into one. And very quickly, since the logarithm containing x squared is positive, there's a plus sign in front of there, that x squared argument made it into the numerator of the final argument over here. The y cubed value, since the log is being subtracted, that y cubed value made it into the denominator of the argument over here, and the z to the 4th power in this log, since that log is being added, it made it into the numerator of the argument in our answer. So this is the answer for part 2, or example 2. And for example 3, just to see something a little bit different, over here in example 2, we had to move the exponents up before we could combine them because they were coefficients on those logs. But in example 3, we have this one coefficient being multiplied to everything. So in example 3 here, we will need to combine these logs before we can even worry about this 3 over 2 power. So when you combine these 3 logs, you will see that the 3 over 2 still is part of the example. And to create a single log with one argument here, the log of a single quantity, the x squared plus minus 1 will be in the numerator. And in the denominator, since this is being subtracted and this is being subtracted, we will have x minus 1 times x plus 1. So now that we have this, we need to see if we can simplify anything in the argument here. So it looks like we can FOIL out this denominator, or you could factor the numerator. Let's do that. Let's factor the numerator. Get 3 over 2 natural log x plus 1 times x minus 1 all over x minus 1 times x plus 1. And it looks like we'll be able to cancel some things there and cancel something there. Oh, everything canceled. All right, so that means we have the natural log of 1. But there's this property that states the natural log of 1 is 0. So that means this entire expression just ended up equaling 0. And if you think about it, this is just a very weird way to represent 0. So I'm glad we were able to simplify it down into our final answer.